why is Namibia focusing so much now on green hydrogen when we have so many other problems out there? So what is the link between solving our basic challenges such as water, electricity, food, and green hydrogen? Can I ask Dr. I'll call them by the first name, Tangwe. Otherwise, I'll stumble over the doctors and the misters and so on.
Thank you very much, moderator. I think one of the spin-off products that we can get from the green hydrogen value chain is really things like water. For you to make hydrogen, you must be able to desalinate some water, right? And I think Namibia has been very one of those countries that have a water scarcity. And I think some of that water can be used by the locals where the hydrogen plants will be elected. I think it's one of the spin-off products that can come from the hydrogen value chain. So really start to touch on the localization of this value chain.
Okay. So Vai, you've been speaking about green hydrogen for food, to provide food. What did you mean with that? Can you elaborate?
Well, I meant that the food that we eat has got hydrogen in it. But also, hydrogen is an energy carrier. And anything that brings us energy helps us to cook our food. For example, we can cook because we have electricity. Because something has to bring the energy to our home. So the hydrogen is an energy carrier that allows us to utilize the energy where we need it. In that regard, we could actually think of hydrogen as an enabler for the bringing of food to the table.
Thank you. Margaret, so we keep on talking about certain industries, right, that's linked to this hydrogen, sort of within the hydrogen value chain. Can you please speak to specific industries that we can link to green hydrogen, especially the link between green hydrogen and green steel, and what does it imply for us? But also I want to know a little bit about how does the formal economy, benefit from this?
Thank you very much. I'll take the last one first. That's the easy one. So when the mining industry established in Namibia, there was an ecosystem and a value chain that had to support the development of the mining industry. And it's nothing different from green hydrogen, or ammonia, or whatever you want to call this. There's a whole ecosystem required in order to sustain this industry in Namibia. And very little, if you look at a big impact, and you look at a direct impact and an indirect impact and induced impact, the biggest impact actually lies with the indirect and the induced impact. And this is where industry doesn't necessarily have something to do with the green molecule, but support that manufacturing and utilization of that green molecule. And it goes from tourism to consultancy, to public participation, to accommodation and guest houses, to accountants and certification and moderators and etc. So for me, that is when we really look unpacking the value chain of Namibia, and we're going to talk about it tomorrow afternoon as well. We really need to look beyond just the core value chain and see how can we actually have this ecosystem in Namibia to support the industry. And if we don't develop that ecosystem, we will cannibalize other industry, which is for me is a two-edged sword. Coming back to direct iron reduction. So basically what it is, very simple. So when you have iron ore on a truck, you have that chunk of black iron that you see, or brown iron, consists of two components. It's ferrous atom and oxygen. So previously what we did is we took that iron, we shipped it all the way to China, we put it in a blast furnace, we added some coke to it, the carbon binded with the oxygen, you have CO2, and you have your reduced iron, or You add hydrogen to it, it binds with the oxygen, it produces water, and we have that highly valuable hot briquetted iron or direct iron reduction. And we can skip the hot furnace in China or wherever it is. My apologies to the Chinese population. It is by example, and ship it directly to ThyssenKrupp's factory and utilize it there. So not only did you process, did you reduce the carbon footprint, but also by cutting out some of the shipping requirements.
Thank you. So talking about shipping, so Rajen, you mentioned was it 3 options of transportation. Can you elaborate a little bit on that, because you only touched on 1 or 2 of them?
Yeah. So the 3 options that we've considered as ThyssenKrupp, everyone talks about green ammonia, and by far green ammonia is actually the most viable way of transporting green hydrogen. And before I go into that, let's just talk about the other options very quickly. The 2 other options that exist is to liquefy, of course, hydrogen and transport it as liquid, but it always becomes energy intensive. So you're using renewable energy, then you're using it to liquefy you're using it to generate hydrogen, and then you're doing liquefaction. It's expensive. The other one is the LOHC, which I mentioned, which is the liquid organic hydrogen carriers. Now, this is it's at its infancy, and it's an expensive, energy-intensive reaction as well, and it's not really proven at large scale. So, which leaves green ammonia. We've done a lot of work or studies looking at green ammonia, and if you look at green ammonia at anything above 6,000 kilometers, there's no other option but to transport hydrogen in the form of green ammonia. And it's just because you get between 10 and 15% losses as well when you transport it in the form of hydrogen.
Thank you. So, Natanya, I'm getting back to you. So we're hearing about the transportation of the long distances and green ammonia, but what about the safety? The safety aspects of handling it all, of storing it, etc.
Yeah, I think one of the things that has not been touched in this green hydrogen value chain is the safety, and we should not put the black light on the shaky part of the hydrogen, because things can start to turn wrong if you don't consider that aspect. So we need to consider the material compatibility of hydrogen. So not only any material that you can use and put hydrogen there and ship or transport it somewhere, because hydrogen, they have a phenomenon that is called hydrogen degradation. So when hydrogen is put into a material like a pipe or a tank, it penetrates the materials, and depends on the material compatibility. Such a material can easily the hydrogen can easily be able to ship out, and that's not a good thing. So what you need is the material that is able to hold hydrogen, and this is achieved through material testing. And I think at UNAM we have a good collaboration with BAM. It's a testing institution that we are working together to look at these materials that are able to hold hydrogen for a certain period of time sustainably. So it's really a very good point.
Yeah, and I think that on the topic of materials, I think that's actually something that folks, especially environmental scientists, etc., have been speaking about and has been asking for more research into this. But we leave it there at the moment. But another concern that is often expressed is that we're splitting the water, right? So now we are releasing so much of the oxygen into the air. Is there a danger to that, Sabai?
The important thing is to realize that there are some cycles that are natural. We have the carbon cycle, the oxygen cycle, the water cycle, hydrogen included. And whenever you are producing something and you are then utilizing, you are releasing an exhaust. If it was utilizing hydrogen, then the the atmosphere. I think that's where your question is going, whether it's a problem to release a lot of water vapor into the atmosphere in comparison to releasing a lot of carbon dioxide like what we are doing now. We all know that carbon dioxide is a greenhouse gas. In other words, when heat is trying to leave and escape from the Earth's surface, the carbon dioxide in the atmosphere will absorb that heat and re-emit part of that heat back to the Earth. And therefore, that phenomenon of global warming comes into play. And carbon dioxide is also the possibility of rejoining with some of the oxygen that is going closer to the ozone layer, and therefore we might actually deplete the ozone layer, thus allowing ultraviolet radiation penetration to the Earth's surface. But now we are releasing water, not carbon dioxide. Is water a greenhouse gas? Maybe it's a question that should have been in the. Is water a greenhouse gas or not? I'm asking the audience at the moment. Is water a greenhouse gas?
You can raise your hand. Is water a greenhouse gas?
Is carbon dioxide a greenhouse gas? So water is a greenhouse gas. It is a greenhouse gas. The question is, what are the effects? Will they be exactly the same effects as the effects of carbon dioxide? And I think the answer is, at the moment, maybe because I love green hydrogen, the effects will not be as severe as what we are seeing with carbon dioxide, even if we release a lot of it. Unfortunately, but the research is still being done in this regard. But the problem that we have of global warming now, we will not have that problem in the next maybe a few centuries if we are just releasing water into the atmosphere rather than carbon dioxide. For lack of having a lot of research work on this particular aspect, I want to leave it there. But let's think about it. Water is a greenhouse gas, but with less effect than carbon dioxide.
Thank you. So, Margaret, what are our key challenges in making, storing, piping, shipping green hydrogen?
Well, as I have illustrated, hydrogen is not at all dense. It is very difficult to bring it down to a liquefied format. You need to literally cool it down to minus 260 or minus 200, around 8 degrees Celsius. And then it has capabilities of penetrating material or binding with material, because hydrogen likes to bind. I always tell the school kids that hydrogen likes to bind. It doesn't want to be on its own with other material. So it makes it extremely difficult and inefficient to transport or to bring to a state where you can transport it. And hence the reason why we're looking at other carriers that are more effective, like green ammonia, or like direct iron reduction, where you actually, the iron becomes the carrier because you actually utilize the hydrogen as source.
So, Rajat, before you mentioned also a unified approach regarding carbon dioxide being emitting industries. Can you elaborate on that?
Yeah, thanks, Bob. So what I mentioned was the largest CO2 emitters exist in sub-Saharan Africa, and sadly to say, they actually exist in South Africa. Now, these are colossal giants, and we've got the same issue of unemployment. So there's no way you can just shut these companies down. You have to look at a cleanup method. You look at CCU, carbon capture utilization. So when I talk about a regional effort, everyone understands that if you're looking at the place where hydrogen needs to be produced, you're looking at Namibia. And regional cooperation, for me, would be using that hydrogen to clean up the CO2 from these industries. So, that's not going to be achieved overnight. There's 2 stages to that process. The first stage would be to look at the downstream value of reacting the CO2 with the hydrogen and look at derivatives. But the long term would be, actually cleaning up those giants by introducing clean hydrogen fuel into the process, thereby decreasing the amount of CO2. Projects happening in South Africa by the likes of ThyssenKrupp as well in global leadership programs, what there needs to be this regional effort between Namibia and those industries to actually utilize the hydrogen produced.
So one thing I wanted to ask you is that you mentioned before that if you are projecting Namibia's competitiveness in the global market, that you are actually foreseeing that we will be quite competitive. Can you elaborate a little bit on that for us? Because I think the audience didn't have the advantage of seeing your slides.
Yeah. So we've got an office in Dubai, and they run the studies for us. So they're obviously very in touch with the studies that were done in Dubai and in Saudi Arabia, and they look at the green hydrogen portfolio for us, where they run all the business cases and they put data together. When we looked at Namibia, so we did a study on obviously on the African continent for Namibia versus South Africa, and more importantly, Namibia came out on top of the world. So when we looked at currently the cheapest producer for green hydrogen would be Saudi Arabia. But when we looked at producing in Namibia, just because of the combination and the effect of the wind and solar profile in Namibia, you approach, I think, $1.6 per kg, yeah, I'm not sure I've got the units right, but which is 10% lower than Saudi. So this is double the cheapest place. And when we speak to all our European partners, all of them say this is where they want the hydrogen.
So, Margaret, what do you think are the major risks that we're facing in Namibia to sort of go on this large-scale production of green hydrogen and making all of the money, the green bucks that he's talking about?
So what Rajan is not telling you is the assumptions on what is the cheapest source of hydrogen had certain assumptions, the sort of equalizing assumptions. One of the assumptions in there is a certain cost of capital. So one of the big issues that can erode that value is the cost of capital, because it is a capital-intensive process. It's an extremely long value chain, and it really needs a lot of capex in it. I think the 5 gigawatt, I think Thomas is here from Hyphen, 5 gigawatts, you guys talking about 7 gigawatts, $7 billion US. I think it's the numbers being thrown around. I don't even know how many zeros are there in a billion, to be honest. So the first risk is that we do things that will increase the cost of capital or not reduce it sufficiently. The second component is the extreme, because of the size of this, the macroeconomic impact on our economy when we start talking about outflows of money and balance of payments. So I'm dabbing a little bit into the Central Bank of Namibia as we're here. This type of money, this project is more than our GDP or very close to our GDP. So you can imagine, and if you talk about these short construction times, there's a lot of money flowing out, and are we ready for that outflow? The third component for me, and then I'm going to stick to, there are so many negatives, and we can solve this. This is not problems, this is challenges. The third component is what I touch on. If we as Namibians are not ready, whether it's to be employed, to invest, or to be contracted, we will start cannibalizing sister industries like the mining industry or other. And we will face a skills shortage, and skills will flow in because it's not driven by us, it's driven globally. Skills will flow in, we will have more people. And then if you take a small town like Lüderitz, and you have all those people in flow there without proper planning, it can just spell one thing, disaster. So yes, we need to plan, and we need to start plan now, we need to start to train now, we need to get ready as Namibians now, and we need to roll up our sleeves and get cracking.
Okay, and I see that I'm at 1:15. So I am going to take a minute just because I have the floor, and within a minute, half a minute, Sivai, can you please tell me, are we going to export all of it, or are we going to keep, is Namibia just going to be exporting to Europe and just feeding Europe? What's your take on it?
I think we are informed better if we think of the size of the project to be done by Hyphen, which is looking at 300,000 tons per year of hydrogen export. And 300,000 tons, even if we love to have a lot of hydrogen in Namibia, we will not be able to use it, even if we wanted it all. We are not ready to use the hydrogen in Namibia. So we need a market for that. So definitely, most of the hydrogen that will be produced, at least within only that project, will be exported. And we do have parts of that hydrogen that we could utilize here in Namibia. And those are the parts that we're saying, let's take advantage of the fact that we now have the hydrogen in our home. Let us now utilize that hydrogen ourselves, even if it means, especially for the power industry, electricity, if we can utilize it as storage of energy and utilize renewable energy during the day, capture the sun, make hydrogen, and then utilize the hydrogen as storage so that we can supply during the night or during low radiation times. This can be one utilization of hydrogen, which is local. And then, of course, all the other industries, like we're saying, Namibia already imports a lot of, or most of, or if not 100% of its hydrogen from South Africa.
Thank you. Thank you. So, finally, Natangwe, can you please tell us, how can everybody sitting here and watching online, how can Namibians actually get more information about this project, but also about what skills they can access? That will be it. 30 seconds.
Yeah, thank you very much. At the Namibia Green Hydrogen Research Institute, we hold seminars every Wednesday at the one lunch hour seminars. That's where we exchange a lot of knowledge about hydrogen projects. And I'm the coordinator for that, so you're welcome to contact me. Thank you.
Thank you. That's it.